Hello everyone, this question we'll be looking into a question about vapor pressure. Okay, so what about vapor pressure? So then now maybe your first question, you go, I learned vapor pressure from the chapter of solution. I also learned vapor pressure from the chapter involving liquid. Right? Okay, so which one is this about? Okay, so then you will have to see, is this about the solution or is it about just a pure liquid? Right? Okay, so now I see the question is asking, what's the vapor pressure of water about a solution? You go, okay, I see the keyword solution. This is about solution. So if it's about solution, we should know about vapor pressure of a solution. Let me just clear over here. Vapor pressure of solution. Okay, so there are two situations. Okay, but before we even start, we should go vapor pressure of solution is we call it as lowering. Okay, so I can go, what do you mean lowering? Okay, so lower, right? So it's a comparison. Compared to what? Compared to just the pure solvent. Okay, so compared to pure solvent. Okay, so now again, what's the pure solvent for this question? Our pure solvent is water, right? Okay, so you go, how do you know? Vapor pressure of water above solution, and what do I have? 18 grams of glucose is in water. Right? Okay, so now I'm gonna draw that. Okay, so then that's our water. Okay, and then we'll have glucose. That's our solute. Okay, so now I'm gonna put some solute particle here. Right, that's our solution. But what's our concern? Our concern is the vapor pressure resulted by exerted by the vapor by water. Okay, so what do you mean pressure? Right, so it's water. Right, will have turned into gas. Right, therefore exerting some pressure. Okay, so now we call those as vapor pressure. Okay, so then again, then you realize, oh, what's this situation? You go, and what are the situations? We have situation one, which you will have non-volatile solute plus volatile solvent. Okay, so then we have another situation, which will be volatile solute plus volatile solvent. Okay, you go, which situation are we dealing with? Okay, so now we need to be able to differentiate that. Okay, so a quick a hint could be, right? So you see, right, if both your solute and solvent are volatile, which means they will have, right, significant enough or a good amount, okay, that liquid will turn into gas. So we'll have is vapor pressure if it's pure just by itself. Okay, so which means the question will need to give you those information. So then that could be a hint in the sense of, did the question give you vapor pressure for pure substances and actually give you two of those info? Okay, so now do we have two? A vapor pressure for pure water, that's one. So which means water is our solvent, which is volatile. Okay, so again, that's also applies to the first situation. Okay, do we have a vapor pressure given for glucose? You go, I don't think so, right? So then what does it hint? It hint your glucose, right? It's now gonna be volatile. So you are actually dealing with situation one. Okay, so it's a non-volatile solute plus volatile solvent. Again, that's how you can tell from the question. And therefore, as our drawing, right? So we didn't draw this glucose turn into gas because again, it's a non-volatile solute, right? Okay, so that's for that situation. Okay, so now we understand that. So then you go, okay, so let's write down the question, right? Okay, so the question is what, or the equation we need to use to solve vapor pressure. That's the next question we need to know, right? Okay, so the next thing is we will use Raoult's law. Okay, the equation itself is the pressure exerted by the solvent, in this case is water for our question, should equals to the mole fraction of water for that solvent itself times the pure vapor pressure of the solvent. Again, that's water. Okay, so I'm just going to use what applies actually for our question. Okay, so then do I have the pure water is vapor pressure? Yes, we do. Right? Okay, so that's 23.8. Okay, so then what do we now have directly given from the question is mole fraction. Okay, so mole fraction of water, how do we calculate that? We're going to use moles of water divided by the total moles. Okay, so we need moles of water plus moles of that glucose. Okay, so now it's not bad, right? I believe we know how to calculate moles of each, right? So then let's calculate moles of water by using given mass, which is 95 grams of water. We're going to use a smaller mass, about 18.2 grams per mole. That cancels out. We got moles. This turns out to be around 5.278 moles. Okay, so then we can also calculate the moles of the glucose, which is 18, and multiply. We have the molar mass given, so it's 180, which gives us 0.1 mole. Okay, so I have this info, plug it in, so that'll be 5.278 divided by 5.278 plus 0.1. Look, mole cancels out. Mole fraction doesn't really have a unit, right? So then that's a fraction, right? So number should be in between 0 and 1, right? We got 0.981. We can plug that in over there. 0.981 multiply the pure vapor pressure. Okay, so in that case, now we get the answer. Do the multiplication. We got 23.4 torr. Okay, so now we're done with this question. That's how you can calculate the vapor pressure lowering. Okay, and then in this case, well, we had non-volatile solute plus a volatile solvent, and then here we have an example question. And hopefully this is helpful, and thank you for listening.